Okay, notes 1.4, exact values using the unit circle. Okay, we've made our unit circle. You might want to get that out. As we're doing our notes, it may help you with figuring out what's in what quadrant or remembering our radians and our degrees, although you will not get to use a unit circle in a quiz or a test. It's very useful when we're going through the notes. I also want to encourage you to write down any questions you might have so that I can answer them in class when you see me next. Okay, so let's start by talking about what an exact value is. First of all, it's exact, meaning it's not an approximation. You won't have repeating decimals or irrational numbers here that you have to round. That's going to be next week when we talk about approximate values using the calculator. Okay, everything we're going to do here today is going to be without the calculator, although you could check it with, and I'll show you how to do that on another lesson. Okay, remember, all students take calculus. Remember that this chart tells us what's positive and what's negative in what quadrant. Okay, we're going to use that with exact values. Before I get too much about what's in the quadrants, I want to talk about quadrantal angles. Here we have 0 degrees, 90 degrees, 180 degrees, and 270 degrees, and we have a column for sine, cosine, and tangent. Okay, so what I want to do is just briefly show you a triangle, and what we're going to imagine is if this triangle were collapsed. What I mean by collapsed is we have an X, we have a Y, we have an R. I want to say what happens when this point is actually at 0 degrees, or at 90 degrees, 180, or 270. And these are really not that bad. They're easier to find than you probably are thinking, and I'm going to show you an easy way to remember them with a cutesy little rhyme. Alright, so remember that sine, excuse me, sine is y over r. We saw this in another lesson. Cosine here would be x over r, or you could think of just using SOHCAHTOA. And tangent would be y over x. And for 0, let's imagine this point all the way down here. Okay, so we don't really have a triangle anymore, but let's imagine that we did and it completely collapsed by moving this point down. Then our y value would be 0. And our x and y would be the same thing. And let's just say that this is a true unit circle, so r would be 1. And so y over r, since y is 0, for 0 degrees, is 0. So what this chart means is sine of 0 degrees is 0. Let's continue with the chart. Cosine, x over r. Well, if x and r are the same thing, that ratio turns to 1. Tangent, like sine, would be 0 because y is 0. Alright. Let's move on to 90 degrees. 90 degrees would be if we move the point up here, and we'd have basically a vertical line. We wouldn't have a triangle at all anymore. It would be completely collapsed, and this time x would be 0, and y would be 1. So what that's going to change our ratios to is we'd have 1, 0, and in this case, the x, since the x is 0 now, have 1 divided by 0, which is undefined, and I'm going to put a u there to represent undefined. Alright, 180 over here, very similar to 0, except over here, kind of like in these quadrants, x is negative. So it's very similar to the 0 degree row, except since x is negative, we still have a 0, we have a negative 1, and another 0. Alright, let's think about 270. 270, very similar to 90, but like 180, we have a negative issue. This time the y value is negative. The vertical component of the triangle, if I collapse the triangle all the way down here, the y value of 0. Y value of negative 1, and our x value is 0. So if the x is 0, we'd have a 0 and an undefined here because of x in the denominator being 0. But since y is negative 1 for 270, we have a negative 1. So, told you about a cutesy rhyme, wasn't lying. This chart tells you how to find sine, cosine, tangent of the quadrantal angles, and this also works if you're in radians, so let's go ahead and put that out to the side. But it's a lot of information, and it would be really easy to get these mixed up. So if you can remember the order of the quadrantal angles, remember the order sine, cosine, tangent, which that's how we've been writing it so far, so it should be easy to remember. I'm going to tell you how to fill in all of these things, okay? So I want you to imagine for a minute, just close your eyes if you need to. I want you to imagine that a friend loaned you some money, some lunch money, okay, last week. And you're thinking in your head, I owe them money. So you say, oh, I owe, okay, like 0, 1, 0 is oh, I owe, like you just thought of it. And then you say, I owe you. Now here the I's are the 1s, the O's are the 0s, and the U is the U in undefined, like is also in yourself. So you owe a friend money, and you just remember, and you say, oh, I owe you. The second part of the chart is that you then remember that you already paid them back. So then you're thinking, oh, I don't owe you. Now, if you're laughing right now about how nerdy this is, keep laughing because this is going to help you on a quiz or a test. This information is really hard to memorize independently, but if you can remember this chart, which I'm going to refer to as the OIO chart, it's really going to help you out. Okay. So that's the quadrantal angles. That's how you would find exact values. And anything coterminal to these, you would do the same way. Okay, so if you had revolutions either in the positive or negative direction, either in degrees or in radians, you were going to use this chart. You do not have to draw a triangle or really do any other work besides refer to this chart. However, if you have something that's in a quadrant, okay, whether it's lots of revolutions or just one, negatives, degrees, or radians, you're going to need to draw a triangle to figure out what the exact value is. And before we go on to some examples, I'm going to do some work, and you can put this off to the side of your paper. I want you to remember about the 30, 60, 90 triangle. Okay, so I told you how our special right triangles are completely related to trig, and if you were unsure how they were related, it's going to be clear today. So I'm going to just fill in the sides, how we've known before, and let's find our trig values here. So sine of 30 degrees. We just go opposite over hypotenuse, 1/2. And before I keep going on, I just want to tell you why this is important. Any angle that has a reference angle of 30 degrees, when you take sine of it, it's going to be 1/2. Now it may be positive, or may be negative. That's what our all students take calculus chart is for. Alright, let's keep going. Cosine of 30 degrees. Cosine of 30 degrees would be square root of 3 over 2. And last, we have tangent of 30 degrees, which, if you think about it, 1 over root 3. I'm going to go ahead and write, though, the simplified version of that. Root 3 over 3. Alright, from here you could find cosecant, secant, and cotangent. I'm not going to write those down. You could find them on your own. These would be a really good idea to memorize. However, your cosecant, secant, and cotangent, that's going to take a little bit of time, but if you remember what your reciprocals match to, then you should be fine. Alright, now let's talk about 60. If you remember from our first day, many of you picked up on the fact that sine and cosine were related. Alright, so the sine of 60, let's look at it and let's refresh. So we have opposite over hypotenuse, square root of 3 over 2. And notice that sine of 60 degrees is the same as cosine of 30. This is just like what we talked about on that very first lesson. Cosine of 60 would be likewise 1/2. And tangent of 60 degrees would be square root of 3 over 1. I'm just using SOHCAHTOA here, so I'm going to write square root of 3. Again, we could do the reciprocals. I'm not going to write them down. This is something that you could find by drawing the triangle and figuring it out, but if you memorize it, it will be that much easier to do. Alright, and that's my suggestion. Alright, let me switch colors here, and let's talk about 45, 45, 90, which is actually a lot less work, because there's only one angle to deal with, 45. So we have 1, 1, square root of 2. And so sine of 45 degrees would be, you could pick either 45, it really doesn't matter, and notice that the opposite and adjacent are the same anyway. We'd have 1 over root 2, which would simplify to root 2 over 2. And cosine of 45 is the same thing. Root 2 over 2. Tangent of 45, this is the easiest one of all because you've got 1 over 1, which is 1. And again, you could find cosecant, secant, and cotangent by taking the reciprocal of these numbers. Okay, so this information plus this chart and these quadrantal angles are going to allow us to do exact values. Alright, so let's move on to an example. Alright, first of all, let's make sure we're reading the directions. It says find the exact value without looking at your unit circle. This is implying that your unit circle may help you with finding reference angles, and if you want to use it to help check your work, that's fine, but you should be able to do it without. So let's go based off of the charts that we know. Okay. First off, we got to figure out what quadrant we're in. This is why we started with that. So 225, if you think about your unit circle, we can, even though we can't refer to our unit circle we made, we can definitely draw it on our own. 225 would be in the third quadrant. It would be between 180 and 270. And when thinking about the reference angle, and let me actually go ahead and make my triangle here. My reference angle, all right, right there is going to be 45. 45 degrees. So really what I need to find is cosine of 45 degrees. Now this is where if you have this memorized, this is a lot easier to do. If you don't have it memorized, you're going to have to draw a 45, 45, 90 triangle and then figure that out. Or you could write it on here. You could write 1, 1, root 2. And then do the SOHCAHTOA on that. But again, having them memorized is a lot easier. Okay, so cosine of 45 is square root of 2 over 2. Alright, the last thing you need to do is figure out if it should be positive or negative. All students take calculus. This is a tangent is positive in this quadrant, not cosine. So that means that while cosine of 45 is positive, cosine of 225 in the third quadrant is negative, and that is your answer. Okay, let's look at part B. Part B, tangent of 3 pi over 4. This is in radians. Now, again, you could change this to degrees, work in degrees. You wouldn't have to change back to radians in this case because we're actually taking tangent of it. But I'm going to really encourage you to stay in radians. You don't believe me now, but actually working in radians is easier, and you end up doing less work a lot of the time when you're in radians. Alright, so let's figure out what quadrant we're in. Okay, so remember, we start with 0. In radians, it's a half pi, or pi over 2, and then a whole pi. So 3/4 of pi would put us right here. Alright, if I draw my triangle, okay, here's my theta, and my reference angle in radians would be pi over 4. That's how much it would take me to get to pi, or you could say pi minus 3/4 pi is pi over 4. Or you could be thinking, also this is in degrees, it would be a 45 degree angle, or 45 degree triangle, alright? And so tangent of 45, this is probably the easiest one to memorize because it's 1. So if tangent of pi over 4, or 45 degrees, is 1, that's my exact value. The only other thing I need to do is use all students take calculus. Since this is an S, this means that in the second quadrant, sine is positive, which means tangent is negative. So my answer is -1. Alright, let's move on. Okay, E, cosecant of 3 pi over 2. Okay, this is in radians, and it's cosecant. So really our first step is to try to figure out, well, what is sine of 3 pi over 2? And once we get that answer, we're going to reciprocate it. We're going to take the reciprocal. Alright, 3 pi over 2, that looks familiar. It is a quadrantal angle. That is 270 degrees. So let's look at our chart. Sine of 270 degrees is -1. Okay, so we need to take the reciprocal of -1. All right. Reciprocal of -1 is -1. Just as a side note, by the way, on the chart, if you take the reciprocal of 1 or -1, obviously it won't change anything. If you take the reciprocal of 0, you get undefined, and if you take the reciprocal of undefined, you get 0. It's not that the reciprocal of undefined is 0, but if you remember why we got undefined, it's because we had a number over 0, and if you reciprocate that, you get 0. Alright, so OIO chart problems end up really being the easiest ones, even if you're having to do a reciprocal. Okay, let's look at F, cotangent of 495. Alright, I have a problem with 495. It's more than 360, so I'm not 100% sure which quadrant it's in. So I need to subtract 360 first. And I get 135 degrees. Alright, so let's put this in a quadrant. Alright, it's in quadrant 2. And if I draw my triangle and think about my reference angle in degrees, because that's what this problem is in, 180 minus 135 would be 45 degrees. And so, again, since it's cotangent, like the last one was cosecant, I need to first figure out, well, what is tangent? Okay? And you can be thinking of either 425 or its coterminal angle 135. Alright, I'm going to go ahead and write 135 here, because that's what it's a little bit easier to think about. So let's think about, well, what is tangent of 135? It's the same as tangent of 45, which is 1. And it is negative, because all students take calculus. Alright, let's look at G. G is secant of 7 pi over 2. Alright, 7 pi over 2. Let's think about this. This is more than one revolution around. Okay, so what we could do to start off with, we could either draw this out or we could subtract 2 pi. Changing this to 4 pi over 2. Okay, 7 pi over 2 minus 4 pi over 2 is 3 pi over 2. Alright, another quadrantal angle. This is 270 degrees. Alright, so if I'm trying to find secant, let's first find cosine. What is cosine of 3 pi over 2, which is the same as 7 pi over 2, or coterminal 2? So looking up at the chart, cosine is 0. Alright, so what does that mean for secant? Secant, then, would be the reciprocal of 0, or undefined. So my answer is undefined. Alright, I realize now that I skipped 2 of the examples. You might have picked up on that. Alright, so I'm going to write those in on this page. Okay, so let's look at C, which was sine of 11 pi over 6. Okay, so remember when you see an over 6, it's going to be a 30, okay? So we know already we're going to do sine of 30. Now, I still need to figure out which quadrant I'm in to know if it should be positive or negative. Okay, so let's look at this. 11 pi over 6 is in the first revolution. It's in the fourth quadrant because 12 pi over 6 would be a complete revolution. 11 pi over 6 would be just short of that. Alright, so this is what my triangle would look like. And what do you think the reference angle would be? Okay, so if you've gotten pretty used to dealing with fractions, hopefully you can see, oh, the reference angle is going to be pi over 6. Now again, if you really hate radians, you can change to degrees, but that ultimately is more time consuming. And you might not have enough time on a quiz or a test to do this on every problem, but it is not a bad fallback if you get confused. Alright, so if my reference angle is pi over 6, which I kind of figured out that it was 30 degrees, alright, with just the over 6, now I know for sure that it's going in the fourth quadrant. All students take calculus. I know that my answer should be negative because only cosine would be positive in the fourth quadrant. That means sine would be negative. And if you have those values memorized that we went over at the beginning, this problem's pretty easy. If you don't have it memorized, like I said, you're going to have to draw it in. So if this is a 30 degree right here, you'd have 1, you'd have square root of 3, and 2, and you'd think, okay, well, what is sine? Sine is opposite over hypotenuse. So if you've forgotten any of those values that I said was a good idea to memorize, it's not that you can't do the problem, you just have to do a little bit more work. Alright, and the other example that I skipped was secant. D, which was secant of 5 pi over 6. So another 30 degree reference angle. We still need to figure out which quadrant it's in. So let's draw it out. Here we have 0, half pi, a whole pi. So 5 pi over 6 would put us in the second quadrant. All students take calculus. So is my answer going to be positive or negative in the second quadrant? Okay, good. My answer is going to be negative because this means sine. This S is not S for secant, it's S for sine. Alright, and secant goes with cosine. Alright, so let's think about our reference angle. Our reference angle is pi over 6, which we could have already known just because of the original problem was something over 6. And let's think, well, what would cosine of pi over 6 or cosine of 5 pi over 6? Let's go ahead and do that. That's going to be negative. And what is that? What is a cosine of a 30? Okay, it might be easier at this point. We don't have to convert everything to degrees, but let's think 30. What's cosine of 30? Alright, square root of 3 over 2. Again, if you did not remember that, you could draw it on the triangle. It just takes a little bit more time. Alright, so I need to take the reciprocal here, because what I really want is secant. So my answer is negative 2 over square root of 3. This is the right answer. It's not simplified, so we need to do that. Square root of 3 over square root of 3. So my final answer here is negative 2 square root of 3 over 3. Okay,